It on? It's on now. All right, we're good. Hey guys, Bryan from LayerZero. It's supposed to be Ryan, so I'm surprising you all and just standing in for him. So Ryan's my co-founder, our CTO. I'm another co-founder, CEO. And we're just going to be talking about using LayerZero to connect Avalanche subnets. So I typically hate slideshows, so this is only going to be the only slide you see. I'm just going to talk. I'd love to field questions, just talk about it generally if people are building subnets right now. But most broadly, I think one of the biggest issues in talking to people who are deploying right now is the needing to roll their own bridge and roll their own infrastructure. I think most people are currently rolling their own bridge and really focused on pure value transfer, which is like, if you guys have ever heard me talk, it's something I've been pretty adamant about. That is like not enough in most cases. So it's cool to be able to connect to C-chain or connect to another one and have like a wrapped synthetic coming in, or some sort of like value transfer between the two. But there's a ton of applications where you will probably want to have generic messaging. So use cases for generic messaging are things like unified governance. I talk about collateralization a lot, where you'll collateralize on one chain and then borrow directly on another chain, as opposed to needing to like collateralize, borrow, bridge, do something, possibly swap, bridge back, swap again, pay back, and unlock. Now you can collateralize and borrow directly. When you're talking about games, a huge amount of people are using subnets or application-specific chains for games. There are a ton of things that you would want to do. This can be propagating actions out from the game. So you live on a high-throughput chain, and that's amazing, and you'd spend 100 hours and 1,000 clicks, and you earn a bunch of things, and being able to take that and propagate messages out and mutate metadata in an NFT that lives somewhere else. So the example I always give is, you might be playing a game in its own chain, but you have like a castle that lives on another chain. So you might have a castle that lives on Ethereum, or a profile picture, or whatever it is. And what you do, your achievements in the game, can send messages out and basically give you those unlocks in other areas. It's like a pretty common case for generic messaging, on top of just obviously being able to bridge NFTs and do things that are not pure tokens. So that's always nice. But I think the biggest thing is just the need for everybody to not need to reinvent their own infrastructure. It doesn't make any sense that anybody deploying subnets, I mean, even ask the layer ones and layer twos right now, how much fun it is maintaining their own bridging infrastructure. And admittedly, like Avalanche has done like a pretty good job at doing that themselves, but there's just been so many issues. It's outside of like the core focus of what the teams have historically wanted to do. And it's just like, well, we need our own canonical bridge. Let's like roll the infrastructure. So the entire point for us is like, we don't care. Like, we're not a bridge. We're not a DEX. We're not like any of these things. We're a pure primitive messaging layer. So we make this seamless messaging between chains, and that means the chain themselves can deploy the contracts, they can own the bridge, they can have their own canonical bridge without ever needing to deal with the security side of things, with the infrastructure side of things, with maintaining sort of like what that looks like in terms of like validation and stack, right? They deploy the contracts that acts however they want. So maybe you guys saw the Stargate launch this week, which we launched on Thursday. I think it just hit like almost 1.6 billion in TVL, but that acts very differently than most bridges in that it's not a wrap synthetic. So your typical bridge is, you'll lock an asset here, you'll mint a synthetic over there, and then when you want to come back, you'll burn the synthetic, and then you'll unlock the original mint. Stargate works in, you have pools of native assets on both sides, you add here and withdraw there. It's that simple. There's a bunch of complexities in terms of like how Delta algorithm does the bookkeeping and like the curve style pricing of the balance to re-incentivize balance. But ultimately, that's what it is. And so there really is no constraint on what kind of bridge gets made on top of this. It's just the ability for anybody to do that. But the focus is purely on the application layer. Solve the problem that you want at the application. Don't need to reinvent the entire infrastructure stack, especially across every single subnet. The other benefit is obviously that we will be deploying. So this is sort of my testament to the Avalanche group. Like, we will be deploying on all of the subnets that have permissionless deploys. Like, we will be connecting all of the Avalanche subnets. So not only will they be connected to each other, will they be connected to the C chain, but they'll also be connected to every other chain that we're on. So right now that is ETH, BSC, Polygon, obviously Avalanche, Phantom, Arbitrum, and Optimism. In the next couple of weeks, that's going to be Solana, Terra, Cosmos, Flow, and many others, right? So it's both pure interconnectivity, like within the ecosystem, and externally outside of the ecosystem. I think ultimately, I know that's like pretty fast. I mean, that's like that's the pitch, right? That's what we're doing. Like, that's what we do. If anybody has questions, I'll just take the questions now because I think like an engaged discussion is far more interesting. But if nobody does, I'll just keep talking about like use cases and things that are cool. So yeah, go for it.
So basically, it's a message passing from one subnet to the other subnet, like the smart contract, and just pass messages to each other.
Yep. So the way that it works is when you interact with, so we deploy an endpoint on each chain. The endpoint deals in validation and messaging. So as a contract, any application, the way they interact with that is they just implement two things, send and receive. So you're sending some generic bytes array, some payload, and you're interpreting that however you want. So whatever logic you can write, the contract layer can live there, and the messages have non-sort of enforcement and valid delivery. So yeah.
Fantastic, thanks.
Yeah, absolutely. Go ahead.
So do we need to add those functions before deploying the contract, or is it able to be added later?
Yeah, added later. You don't need to do anything. So subnet gets deployed. We'll deploy an endpoint, which again, for every subnet that's EVM compatible, that's very, very easy to do. It's just a fork of the existing, as long as, well, whatever. I think all the subnets treat the RPC stuff the same and the routes the same. So yeah, it will basically just be a simple fork on our end. We will have to get, there's people need to like pass state data out of it, but we'll be incentivizing people to do that. And then every contract just interacts, and immediately, as soon as there's an endpoint, that subnet, anybody interacting with that endpoint can now talk to any other endpoint. So every chain that I listed, every subnet that we're enabled on, everything. So yeah, immediate. Yeah, absolutely.
The other one is anything related to MEV and the delay in messaging.
Both amazing questions. So need for an oracle. We call them oracles in our system, but it's like a little bit of a misnomer. An oracle is just any system that can pass a block header in the same way that a relayer is any system that submits a transaction proof. So people think about it from the traditional sense, and we are, Chainlink, Band, Flux, all of these are enabled. We're working with all of them, right? But also additionally, like anybody can run an oracle. Anybody can fulfill that role, and it can look like anything. You can be going from Solana to Cosmos, and your oracle is like the complete set of Solana validators, and your relayer is a complete set of Tendermint validators. There's no constraint on what that looks like. The important part is just that the application opts in. So subnets who want to backstop their own security, who said, we are worried about using any other external thing, what they would actually do, the easiest thing for them to do is simply say, okay, we're going to run the Oracle component, and we're going to backstop basically that. We're going to pass the block headers. We're going to do that on behalf of the network. And then they use whatever relayer they want. Maybe that's LayerZero Labs. Maybe that's Coinbase or any other infrastructure. Maybe it's Aave or Sushi or anybody who's like running their own relayers. They can opt into whatever relayer they want. But what they have now by running their own Oracle or relayer, whichever component they run, they have basically complete control. It doesn't matter if 100% of other people involved in the network are completely malicious, unless they're colluding with that malicious party, like against themselves, there's nothing anybody else can do. They're cross-referencing every single transaction that comes in because it has to be able to walk to the header that they're providing. So it gives them sort of complete autonomy or like control of security over their own, whether it's subnet or application. So for anybody who wants to roll that piece, like that just gives them that lever. But most people, or I'll say most applications, right? Most small applications, it's really the ability to price risk. And so a small application is going to say, you know what? Using Chainlink as my Oracle and using Coinbase as my relayer, like I'm okay externalizing or pricing the risk that both Chainlink and Coinbase will not be simultaneously malicious and colluding against me, right? There's some price I'm willing to pay to not roll this. But again, when you're the Avs, the Curves, the whoever it is of the world, you have the ability to simply just run one of those components yourself. Let's say you extend your multi-sig, and your multi-sig now runs one piece. You have effectively no extension of trust, and you have complete security over every single message sent. The second piece on MEV. So MEV is, like latency is not really the issue in MEV. It doesn't matter if you have 10 minutes or like 1 second to most of the bots operating in MEV, like it's the exact same thing, right? It's a matter of milliseconds. And so MEV is typically created by like disjointing some true price and then capitalizing on that. So somebody's transaction is coming in, they have a threshold that's a certain amount, you will disjoint the price and you'll basically have this execution that's like advantageous to you or like reordering of things. There's two things with us that are really nice. One, because of that, like even if you had a full 1 minute heads up that it's coming in, you can't do that early because you're just dislocating fair price and like you're creating MEV for somebody else. Like somebody will just extract it from you. So you really need to be like in that block in the exact timing. So the timing window is still the same, but also incoming, any transaction coming in, we can just submit, the relayer can just submit it directly to whether it's Flashbots or like MEV resistant RPC. So there's the ability to do that as well. And then the other component is that every single thing in our system, so if relayers were not non-sorter enforced, which if messages were not non-sorter enforced, then there would be this huge gap where oracles and relayers could basically reorder transactions coming in. They could hold some back, etc. That would be a huge MEV window, but every single message sent is non-sorter enforced from the source chain. So it must be submitted and can only be processed in the exact order that was submitted on source chain. So there is no reordering. There is no way for basically a relayer to say like, I'm not going to do this. I'm going to skip it over. It cannot happen. So yeah, it's something we've thought a lot about.
Yeah. Is it me?
You, yeah.
Yeah, all right. So I have a question about dApps building on LayerZero. So we know that there is Stargate, fully composable native asset bridge. So can you explain us your plans or like any improvements about dApps built on LayerZero?
Yeah, I mean, I think the biggest thing, so like, yeah, Stargate rolled out. Stargate's meant to be like this liquidity transfer layer, which really is, we realized if we gave people pure generic messaging, it's interesting and you can build a lot of cool stuff, but like, it's pretty hard at some point. You ask a DEX to do it, the really naive way a DEX would do it would be like, whatever, a pool of ETH here and like a pool of SOL there, and that becomes like your ETH SOL LP. And to do that, they need to like, fundamentally implement single-sided liquidity pools, which they don't support. You need to incentivize those pools. You need to create this LP across every chain. It's like a really, really big lift for any DEX to do. So like maybe a less naive way would be like, all right, we already have like ETH to USDC over here. We already have like SOL to USDC over there. Like, let's just make USDC pools and then go between. And they still need to implement single-sided liquidity pools and incentivize them and do all of that. It's pretty capital intensive. And if Uniswap does it, well then SushiSwap and Trader Joe and QuickSwap and like everybody else needs to reinvent this, right? So the whole point of Stargate was just abstract that away. Now, when you want to integrate it, let's say for Sushi on chain A like gets an ETH and spits out USDC. The USDC isn't, and that's atomic. That's like exactly how Sushi works now, no changes. The USDC is taken and moved over Stargate. It's effectively adding on one chain and subtracting on the other. All messaging risk, all risk to liquidity is housed within Stargate. Sushi on chain B gets in USDC, spits out asset X. That's atomic. That's exactly how it works now. So what that means is for Sushi to integrate this now, zero changes to core protocol, zero liquidity, zero risk at the messaging layer at all. You just wrap the two contracts, compose Stargate, and you're done. So really useful for DEXs, really useful for anything that does liquidity transfer. So a yield aggregator is a really good example, or just like you're monitoring 20 farms across 8 chains. Like what you want to do is unstake $10,000 of tether here and like stake it over there, right? You don't want to necessarily have to solve, how do I get that tether from here to there? And that's like the tricky part. And so this just makes it where the application focuses purely on the contract interactions, and the liquidity transfer portion of like teleporting this capital from this chain to that chain is just abstracted away. And then go even a, level above that. Wallets don't even want you to go to SushiSwap or want you to go to like the yield farms. Like you want to go asset A on chain X, asset B on chain Y, do it here in the wallet. You want to go from this farm with 15% APY to this farm with 40% APY, just do it here in the wallet. And you're able to abstract all of that away from the user. They don't need to know what chain they're on. They don't need to know what underlying gas asset. That's one of the nicest things about LayerZero is this ability to take this complexity. So you can have like a really complex set of contracts across multiple chains. Let's say 6 contract interactions. That's like unstake, swap, initiate a bridge, claim a bridge, swap, and stake, right? And compress all of that into one bundle from source chain where the user only ever signs one transaction. They only ever pay gas and source gas. They don't need to have both ETH and AVAX in their wallet or AVAX and Matic, right? Doesn't matter. And the whole flow gets executed. And they can get airdropped gas to continue to interact in that platform on the other end if they want to. So it's the ability to roll this whole bundle. Go ahead.
Yeah, so where does the SGT come in?
Sorry, where does STG come into the Stargate side of it itself? So STG right now is about 12% in emissions, 12% total in circulating supply, and that came from 5% went to the DEX early, some was sold on the bonding curve, and then there's 2.11% emissions over like the next 3 months. Right now, Stargate is pure emissions. If you look at the structure of every single transfer that gets sent across Stargate, 4.5 bips goes to the LPs, 1.5 bips go to the treasury. The token holders obviously have the ability to vote to do whatever they want. So I believe there are proposals coming out this week of both new assets being added to Stargate and people sort of deciding what happens to that 1.5 bips fee within the treasury.
Hey Brian, nice to see you again. I have a question. We know the protocol, it's pretty obvious it's redefining DeFi, but are there any other niches within blockchain that it applies to apart from DeFi itself? It's a very powerful product.
Sure. Okay, when we first started working on this, the lens was like very clearly pure DeFi. You know what I mean? Like that was just the obvious use case. That was the thing we were solving. Since announcing, 50% of our inbound was gaming and NFTs, and people have thought of things that I had like not thought about at all, not even a little bit. So there's a ton of really cool stuff happening in gaming and NFT space around this. The wallet side, the marketplace side, NFT aggregators or wallets who want to basically represent things. Everybody who wants to basically become chain agnostic has been super interested. And then the TradFi thing. So there's a bunch of stuff that I can't talk about yet, but inbound from TradFi has been like, if you had asked me 6 months ago, I would have told you at least 5, probably 10 years away from the level of interest that we've had from literally all of the largest financial institutions in the world, all of the largest consumer fintech companies, all of that. So I think there's a lot of sort of angles that we haven't even really started to sort through. Really for us, it's more be everywhere, create the best possible primitive. Like you want to create the most extensible primitive so that put the power in the hands of the people who are building. So the other example I always give is like a huge pet peeve I have of existing systems is that everybody's opting into the same set of security parameters. If you heard me talk on the panel yesterday, you heard me talk about this. But the example that I always give is right now, there's one construct that defines everything. It says you're going to wait this many blocks, you're going to do whatever, right? It's defining your entire set of security parameterization. This is, okay, we're using this X number of validators or guardians or whatever they are, and this is the block comps, and this is how it works. And everybody, it doesn't matter if you're like verifying on chain B that you own a copper sword in a game on chain A, or you're transferring hundreds of millions of dollars, you're using the exact same set of parameters, which means either somebody is wildly overpaying for security or somebody's not getting nearly enough security. And so one of the things that I have been most optimistic about is in the solution that we've rolled out is that all of that moves up and has modularity at the application layer. So every application decides exactly the subset that they want to use for oracles and relayers, who they're using, what that looks like. You basically create this Pareto frontier, and you select on the bound of cost and security, which is always the trade-off, where do you want to live, right? What are you willing to pay for to get that, and what are the needs of the application? And then if you want to wait 5 blocks, 50 blocks, 100 blocks, totally up to you. Like each application has the ability to just decide that themselves. There's no reason why that should be decided at the technology layer. It clearly should have modularity there. Yeah. Okay, if no more, I'll just keep talking. If anyone has one, like just throw your hands up. Totally, yeah, go. Yeah, so for us, I'm going to separate the two entities of LayerZero and Stargate, right? LayerZero will deploy an endpoint on that chain. That means anybody can interact with it. So when you're talking about pools, Stargate has standing liquidity, but like for the subnet, maybe you want to have a canonical bridge like Avalanche has between ETH and AVAX, right? So maybe you just create these two contracts that say, hey, lock something up on the C chain, and we're going to mint it over here, and vice versa, right? Maybe you're a game and you're just deploying an NFT bridge that says, hey, you can outbound these NFTs and go trade them on OpenSea, or you can put this in another chain's other game, the metaverse, or you can inbound things or whatever, right? It really, each application can decide whatever they want. So a bridge is just a set of contracts that's being deployed on top of that and interacting with the endpoint to like coordinate between the sort of endpoints on multiple chains. So it really is kind of up to people to build whatever they want. That said, all of this stuff will be deployed in many cases, it will like not be hard to write, right? You're going to have existing endpoints. So you're just like, oh, like this is the bridge. I'm just going to move that over here and like use it for my needs, within a matter of, let's say, single digit weeks, you're going to see all of this will have sort of existing contracts that are very easy to pull from. So there won't need to be this whole vector of like needing to roll it out yourself.
Where can I find your guys' tokenomics? And then follow up to that, do you consider it a problem for centralization that Alameda essentially snipes supply?
Okay, so talking about Stargate specifically, not LayerZero, right? Yeah, tokenomics you can find in the docs. So that will be in the Git book. You can go look it up. It's all there. Do I consider it's certainly not ideal, for sure. Like that's obviously not what we wanted out of that auction. Basically came down to like probably 24 hours before we knew there was a huge amount of interest broadly. I think if you just look at the mempool, there was a lot of people trying to snipe that auction or trying to participate in that auction with high gas. And so basically the decision was, hey, do we wait? Do we push this back, let's say 3 weeks, write a new contract that has all of this stuff for whatever form, like, the problem is everything's just exposed to a Sybil attack. Like even if I made it a $1 maximum per person, like it's so easy for whatever, huge service who's used to writing scripts, like they'll just write it and they'll just take all the things at $1 a piece. Like I guess there's like a gas constraint where if people are like losing value compared to the gas that they pay, maybe you won't, but like anything that's Sybil becomes even easier for somebody doing it programmatically. It's even more advantageous for them. So certainly not ideal. I think sort of the way that it's structured now where like they're not going to touch the tokens for 3 years and they're giving up governance rights is reasonable. It means like you have 3 years, by that time there'll be enough emissions that will all be a small fraction of like governance and circulating supply and everything else that I think it is let's say a reasonable outcome. I think it's like in a fine state right now, but certainly not ideal for sure. Yeah, go ahead.
Can LayerZero connect with Bitcoin as well?
Yeah, so we had always said prior that you really needed enough smart contract capability to validate a proof directly on chain. And we've changed that a little bit to where we're fairly confident now that we can deal with UTXO chains and we can connect with Bitcoin. But obviously the subset of things that can be done there is vastly reduced, right? Like Stargate, the complexity of a Stargate contract will never live on Bitcoin. It just won't. But could you do something that interacts with something there that acts like a Ren Bridge or anything else, brings Bitcoin to every single other chain? Yes, yeah. We're pretty confident we can do that, and we are exploring it now, I'll say. Yeah.
Do we have choices if we deploy this on a subnet that requires compliance in terms of where the endpoints interact?
Yes, yeah, I mean, so at the endpoint layer, okay, so if you have compliance, your contracts on the chain are probably permissioned. Is that correct?
We need like KYC on the validators, but we want to be able to deploy stuff like users would have to be KYC.
Users have to be KYC'd and contracts would have to be permissioned, right?
Well, the contracts could be permissionless. We want to give that up.
Interesting. Users are KYC, but contracts are permissionless. So normally, we would deploy an endpoint, and anybody can interact with that endpoint. Now, we deploy an endpoint, contracts are permissionless, but users are KYC'd. So only KYC'd users would be interacting externally, and the applications would basically deal with how they're accepting messages in. Your validator set could block it, so that could be enforced at the validator level. There could also potentially, like the endpoint could be modified to only connect to certain chains. You guys could act as the oracle or relayer and only interact. So you could act as one of those pieces and say, I'm only going to pass block headers, or I'm only going to pass transaction proofs from these chains, right? Or even these contracts on these chains. And then you just don't do everything else. And then the validator set like discards anything coming else from anybody else but you. So that can be enforced at the validator level. It could be enforced at the endpoint level, but yeah, either way.
You're impressive. What do you consider your competitors?
So I think it's pretty interesting in that prior to starting, one of the biggest things that we had is that everybody was focused on value transfer, and I had no idea why. Everybody like only talked about, I mean, you know, you're gonna have a user, and they're gonna take a bag of money, and they're gonna walk across a bridge and like go to some new magical land. And to us, there was always just like a special case of generic messaging. Like generic messaging was clearly the thing that was interesting, and like that encapsulates value transfer. That's totally fine. And prior to us announcing, like there wasn't a single person who talked about that. And then like post, like go check the archives of web pages, like post us announcing, like you won't find a single website today of anybody doing bridging who's like not talking about generic messaging, right? So like if you read, everybody's doing it, but like you can't find me an interesting application that deals in generic message passing now. Like there isn't, right? It's literally like Stargate is the first one that does it on any compelling layer. So if you Google search, the competition is like any bridge that exists. In our mind, there aren't really that many significant competitors. I think people are trying. Like it's a huge space to win. Axelar again is largely focused right now. Like Axelar applications are bridges right now. That's right. You take UST and you get like Axelar UST on the other side. There's wrap synthetics. I've talked a ton about why I don't really love wrap synthetics in general. I think Axelar does have the ability to do generic messaging. So maybe at some point. But again, you can read a lot about what I've said on like the differences of any. So when I was talking about hyperparameterization at like the technology layer, it's the same thing. Everybody's opting into one construct. So I talk about this a lot, you know, middle chains. It doesn't matter what it is. It doesn't matter if it's your own chain, if it's a set of guardians, if it's a set of whatever it is. You have some consensus mechanism that sits in the middle of everything. You write a transaction on source. That consensus mechanism says, yes, that's valid, or no, it's not. And then it writes a transaction out, right? And that is like a really big issue because that consensus mechanism is the ultimate signer of every single application on every single chain. If that breaks, they have the ability to take everything. So massive systemic risk plus any contagion that happens after that, which would be huge if that's widely adopted. And it's this really adversarial property of like, maybe you secure 5 billion, but then like Uniswap opts in and now it's 20, and Aave opts in and now it's 50. And every new person opting in is creating a really adversarial set of incentives for every existing application, unless the bond in that middle chain is growing like non-linearly to the value that's being secured, which has never ever been the case. Like nobody does that. It would be super capital inefficient. And so that becomes like a really, really big issue, not to mention that consensus itself is a really big, like, it's a hard problem. Like, look at the amount of reorgs that happen on other major chains, like, every single week, right? So when you're in, they have all the proper incentives, everything that would you want to sort of not have that happen. So when you're talking about some consensus mechanism whose only job is passing messages back and forth, and everybody must opt into that or just like don't do anything, you like eventually at some point that just becomes the largest honeypot the world has ever seen, right? It's just like this catastrophic portion of risk. So I'm like very bearish on broad middle chain models. I've been super vocal about that in general. But yeah.
You think the multiple systems can coexist? If Jump drop $2 billion or more to basically to expand, you think it can coexist multiple systems, or
So
LayerZero will be one LayerZero?
I think it is a very much a winner take most market. Yeah, I think will multiple coexist? Absolutely. Will somebody win the large majority of it? Almost certainly. Yeah. Yeah, of course.
You just mentioned reorgs. How do you think, like, how does LayerZero in general think about reorgs?
Yeah, so there are defaults for every chain, but ultimately we move it up to the application layer. So like in probabilistic finality, latency is just a measure of security, right? So every application has to decide like what that, like they can use the defaults, which are set on like the fairly conservative side of things, or they can choose it themselves. But ultimately, like all the risk is born at that specific application. If you do something on source and that gets reorged into a different state and you've already done some mutation or some effect on a destination chain based on like a different view of the world of what you thought source was, like something bad's gonna happen in your application, probably, like depending on what you're doing, right? And so we don't think it makes sense at all. Again, in the same model I was talking about before, like why do we decide that? Like there are certainly applications you say like, listen, I don't care, I'm transferring infinity money, like I'm gonna just wait 300 blocks, like you know what I mean? I'll just wait as long. It doesn't matter if it takes a day, like I'm fine with that. ultimately, each application should be able to decide that, and that's just how we treat it. So like every application has to decide what's the risk threshold, what is the price that you're like, what are you pricing there, what are you underwriting when you're doing this interaction, and how do you want to treat it? So, yeah, pure modularity, ideally. I have no clue where we're at on time. Go ahead. Yeah.
I have another question on comparison between bridges. So there's the Synapse, for example, and I've used that, and to me it seems to have liquidity pools on both sides, so it seems a little bit similar, but I assume there's a difference. Can you elaborate?
Yeah, absolutely. So I think a lot of the existing bridges ran into the same thing. Bridges, so again, you'll like, when I talk about LayerZero is not a bridge, right? It's a message. Stargate is a bridge, LayerZero is not a bridge. And the reason I say this, like most bridges want to be just really nice applications. Like they want to have liquidity pools on both sides, or they want to lock here, whatever bridging construct they make, they want to be a beautiful application with like a great user experience. And what happened is they wrote these contracts and then they said, oh, I've actually got to figure out like, how do I get messages back and forth? And then just like as an afterthought, they created their own transport layer, right? And that's been the entire problem with all the hacks, with everything else, is like the transport layer has always been an afterthought. And people were thinking application first. And for us, it's the opposite, that I want all of these bridges to like redeploy on top of LayerZero and like not think about this anymore. Most of them want to be the application, not the transport layer. Obviously, you can probably present better tokenomics when you're like, we'll have our own chain and we'll do lots of stuff in the chain, and like that's why. Ultimately, I do, like whether some teams were just like they're application developers that were not qualified to create a transport layer. It's like pretty hard technologically, the side of things. And some of them just like didn't want to, but were forced to do it because they didn't exist at all. So I would say Synapse is like more akin to Stargate than LayerZero. But yeah, I think fundamentally, like I would like to see many bridges exist on top of LayerZero, because I think there's a compelling application side of things to be done there. Yeah. Yep.
Outside of application-specific implementations of protections on reorgs, what would you consider your current points of centralization or attack vectors?
Yeah. Yeah, 100%. Are we at time after this? Okay, so last question. That's fine. So right now, we consider ourselves in beta. We've sort of published that. What beta means to us is that there is a limited set of oracles and relayers that will be expanding heavily over the coming months. And basically, again, we'll be open sourcing everything to like anybody can easily run the relayer side of things, can run the oracle side of things, can sort of own any piece of this. It's still open and permissionless right now. Like anybody can do those things. It's just like pretty hard to do. There aren't reference implementations. It's not that easy to just like spin this stuff up from scratch. So right now at the application layer, it's basically the spread of the relayers and oracles. They can still own their own piece. They can still sort of have that. But I think the broad thing, like you're still going to have pieces that are widely used. So I'll use, whatever. I'll say some popular oracle sits in the middle, right? And like if you only use that oracle and it breaks, maybe everything breaks, right? And maybe it costs, I don't know, $2 billion to break, and you get like $5 billion to break it. So like it's pretty compelling, and like maybe people will break it to get the $5 billion at some point. But now you have this construct where you have this oracle that lives there. It still costs $2 billion to break. This like that doesn't change at all. But now you have this broad set of relayers, and now if the oracle breaks and is collusion with relayer A, like only that very narrow band gets affected, right? So it's like a very small slice of risk, this band of risk. It's mostly application specific if the application is running their own relayer. And like anybody using relayer B through Z, anybody relaying their own transactions, anybody using any other oracles are like totally unaffected. So what you do is you take the cost to break that oracle, which is still $2 billion in this example, and now what you win is you actually only win like 1/30th or 1/300th of total risk, right? So you've taken the effective cost and made it exponentially more expensive, which is an extremely, extremely attractive property when you're talking about like capital efficiency of these systems and like sharding of risk. So I think when you're talking centralization, like most people think about it as like there's one pool of validators and they just like own all the validators, or like that validator set is heavily centralized. And we don't there is no consensus mechanism in LayerZero, right? Each of these components can look as broad and distributed as applications want them to be, or as like people are compelled to make them. And I think over time they absolutely will be. And so there's really I see centralization as what is the spread between oracles and relayers, and how do you make that as broad as possible, as many sets as possible. And I also think there's there's like something pretty interesting about the avalanche model of like having one chain and then like the subnets each being like subsets of validators, and you could absolutely do that as well, where you have like a broad set of validators who say like, I'm going to participate in operating a relayer, and then any application can say, I want to take like this subset of nodes in that at a cheaper cost, and like that's fine, right? So there's a bunch of cool things you can do there. But I think it's thought about in a little bit of a different way, in that, again, even if it was heavily centralized and heavily malicious and like everybody was a bad actor in this like central cabal, each application can just be like, I'm just going to run one piece and there's nothing anybody else can do to me, right? Like I have complete control over this. And so I think that's the biggest thing, is like there isn't this consensus that they're opting into. It's this sort of aggregation of systems, and that's really like what the security model is. So, all right, I think that's time. Thank you guys.